When you see the 3D design of your future home for the very first time, the feeling is pure excitement. The lighting is immaculate. The flooring is flawlessly seamless. Every piece of furniture sits in exact alignment. It is picture perfect. These high-fidelity renders serve as a digital representation, a visual target for the construction phase. Software is excellent at giving you the layout, testing out material combinations, and setting the intended mood of the space. The friction starts when construction finishes, and a homeowner points out a detail and says, "It didn't look like this in the render." They are usually right. The render showed the design under strictly ideal, mathematically perfect conditions. The actual construction site operates under the rigid laws of physics. Gravity, structural loads, and material properties mean that a flawless digital vision must adapt when it hits reality. Take your floors. Software can stretch a continuous, buttery smooth marble texture across an entire room. In the physical world, large tiles require grout lines. Real marble slabs have natural joints and veins that do not match up perfectly. Your room's specific dimensions dictate exactly where those edge cuts fall against the walls. The same tension exists when you look up. A 3D model presents perfectly symmetrical false ceilings. What it hides is the mechanical chaos required directly above it. Strip away the drywall and you find load-bearing beams, thick AC ducting, sprinkler pipes, and electrical conduit. If an AC duct reroutes to avoid a concrete beam, the ceiling drops. A recessed light hitting structural steel forces the fixture to shift. These deviations are rarely mistakes made by the execution team. They are the strict requirements necessary to keep the structural integrity intact while making the home functional. Lighting inside a computer is easily manipulated to cast a dramatic, moody glow across every corner of a room. Physical light is far more volatile. This chart illustrates how light temperature interacts with pigment. You can select the exact same beige paint code for your walls, but under a warm 2700 Kelvin bulb, it skews heavily yellow. Hit that same wall with 5000 Kelvin daylight, and it shifts to a stark gray. Everything from bulb wattage to the angle of the sun completely alters the room's atmosphere. Then there is the physical scale of the furniture. In software, you can subtly scale a sofa down by 3% to make the room look beautifully spacious. But order a physical sofa that is just a few inches deeper than the initial plan, and the entire flow of the room tightens. The passage between the couch and the coffee table shrinks, creating a frustrating bottleneck every time you walk through. The 3D render successfully locks in the aesthetic, but your actual daily comfort relies heavily on the rigid physics of light and precise human-scale measurements. Software textures are infinitely repeatable. If you copy a wood grain or a marble slab in a render, it looks identical from every angle. Real materials carry unpredictable natural variations. 2 veneer sheets never perfectly match. A small 2-inch laminate sample will look noticeably darker across 10 feet of cabinetry. Even the room itself holds irregularities. Computer walls are perfectly straight, but in a real house, walls are rarely plumb. Corners almost never meet at a true 90-degree angle, and concrete floors naturally slope. Bridging that gap requires highly skilled, coordinated execution. Carpenters, plumbers, and electricians have to constantly measure, shim, and adjust on site to make perfect cabinetry sit flush against imperfect, sloping walls. A highly refined interior is achieved by embracing the unique character of natural materials and relying on expert craftsmanship to navigate those structural realities. None of this makes 3D renders useless. They are incredibly powerful tools for locking in your color palette, confirming the stylistic direction, and defining the layout before anyone picks up a hammer. Effective implementation requires approaching the 3D design as a flexible directional map. A project succeeds when the finished home preserves the intent, mood, and spatial balance presented in the initial design. Often, an experienced designer will lean into the friction of the construction site. They will simplify a complex wall panel or adjust a tile layout based on the physical space, resulting in a cleaner, more refined look than the initial render. Translating a sterile digital dream into a warm, deeply comfortable reality requires immense technical knowledge, on-site flexibility, and expert human execution. Have you ever seen a 3D design that looked different after execution? Let us know in the comments. And if you enjoy digging into smart design decisions and the mechanics of real-world execution, make sure to subscribe to the channel.